Lesson 72, Factors that are Sums, Pyramids, and Cones. This is another one of those lessons with two very unrelated topics all in one lesson. So let's just get started. The first ones, you're going to hear this word a lot, factor. I love the factor, so it's one of my favorite things to do. So hopefully it'll be one of your favorite things to do too. These kinds are called factors that are sums, and if you look, what we have here is we do have a trinomial because we have three terms. This is one term, term 1, term 2, term 3. So it's a trinomial, and what you're going to notice, remember the last lesson I said we need to look at each term and see what's common. When we look at each of these terms, the thing that's common is a sum, which is a plus b. Common in all three terms. Since it's common, we can take it out. So I'm going to take it out. What taking it out means is we're going to remove it. We're going to take it out here and make it a factor. So it's going to be a plus b is a factor that we can remove. So we're removing it from all three of these. Then we write in our remaining parenthesis what's left. So if we remove the a plus b from this term, we're left with x squared. If we remove the a plus b from this term, we're left with an x. And in the last term, we're left with a minus 6. So once you remove the sum that's common, we have our normal trinomial that we factor using our reverse FOIL. Just remember to bring your a plus b with you. And then we do two sets of parentheses. Remember, this is reverse FOIL. So what times what would give us our first? So that would be x times x. We look at our sign. The sign is negative. That means one's going to be plus and one's going to be a minus. The last sign's a difference. The sign are going to be different. And then we need what times what gives us 6. And when we subtract them, we get negative 1. So that's going to be 3 and 2. Let's just check it. First, give us x squared. Outer is minus 3x. Inner is plus 2x. That gives us minus 1x. And last is minus 6. You can see these are pretty easy, right? Not bad. Let's look at another one. What's common in all three? This is another trinomial, three terms. The common thing is our x plus y. So we're going to take out what is common. So we're going to put our x plus y over here. And we're going to write down what's left. If we take that out, we're left with x squared. If we remove the x plus y from the next one, we get 9x. And finally, we're left with 20. Why don't you try factoring this trinomial, see if you can get it. Pause the video and come back in a minute. Alright, so hopefully you factored that. So we get x plus y. And I'm going to factor this into x plus 5, x plus 4. The way I did that was I looked at the last sign. It's positive. They're going to be the same. What are they going to be? Look at this one. They're both going to be positive. What times what gives me 20, and when I add them together, I get 9. That would be 5 and 4. So that one's done. See how easy these are? Let's just move on to the final example of this type before we go on to pyramids and cones. Okay, again, looking, we have a trinomial because we have terms are separated by plus and minus signs. So we have one term, two terms, three terms. What's common? Well, this one's a little bit trickier. We have an m and an x minus 1. An m and an x minus 1. An m and an x minus 1. So we're going to take both your m and your x minus 1 out and see what we have left. That's all out. Left over, we're going to have an x squared. This one, we're going to have a 7x. And the last term, we're just going to have a 10. And again, we're going to recopy everything. X minus 1. Two sets of parentheses. Last sign is positive. What are they both going to be? They're both going to be positive. We're going to have an x times x gives us x squared. What times what gives me 10? And they add together to give me 7. That would be 5 and 2. We can check that. Outer is 2x. Inner is 5x. And that gives us our middle of 7x. So yes, we did it. See how easy those are? Not bad. Okay, let's go to are factors that are sums and are pyramids and cones. This one's a little bit trickier, but let's give it a try. Uh-oh, I lost my page. Let me see if I can find it. Lesson 72B disappeared. Hold on a second, everybody. Let's see if this works. Aha! I found it. Okay, let's go over here first of all. We're going to talk about the volume of pyramids and cones, surface areas of pyramids and cones. If you look down here at this drawing that I took out of your book, what we're going to deal with are regular pyramids. What a regular pyramid is, all the polygon that forms the base, all the sides are going to be equal. And these are all going to be equal. Let me get the color that works here. These are all going to be equal. And all the triangles are going to be isosceles triangles. That was really on that back side right there. We have some parts. The lateral edge is this slant part right down here. This is the slant height. It's the height, the perpendicular height of a side. We have an altitude. This is called the axis of altitude. It makes a right triangle with the side. And this is the lateral face. This is the vertex. Those are the points. So if they want us to find the volume of a right rectangular pyramid, all we're going to do is we're going to find the area of the base times whatever the height is. It's going to be the altitude height, not the side height, not the slant height. It's going to be the actual altitude in the middle. So these aren't that hard. The volume of pyramid is equal to 1/3, so you take 1/3 times it. So let's try these. When you take a test, I'll give you the formulas for these. I don't expect you to memorize all these. So let's try the first one. The first one, volume. The volume is easy. First we want to find the area of the base. So I'm going to just put volume, 1/3, the base. That would just be it's just a rectangle. So it's going to be 9 times 7 times the height, which would be 8. And you would just multiply all those together, and we're going to get 168. And if you're talking volume, it's always cubic. That would be inches cubed, because we're going to have 9 inches. You don't have to write these in until the end. Inches and inches. Inches, inches, inches would be inches cubed. So this, you just simply put 9 times 7 times 8 in your calculator, divided by 3, and this is what comes out, and that's your volume. So it's not that hard. You just have to multiply it by the 1/3 because it's the pyramid. Let's go over here and talk about cones for a minute. Alright, we got ourselves some cones. Cones, we're going to deal with right cones, regular cones. This kind of right cone that has the altitude is perpendicular to the base. That's how you know it's a right cone. The lateral surface area is this part that wraps around. This is the vertex, the altitude, and it does have a slant side too. The formula for that is the same thing. It's area of the base times the height. So this right circular cone has a base of radius 6 feet and its height is 8 feet shown there. So if we're going to find the area of the base, what it is the area of a circle. So we're going to use the circle formula to find the base. So the circle formula would be, well, let's say volume equals 1/3. Area of the base would be pi r squared, right? A circle is pi r squared. So it's going to be pi times 6 squared times the height, which is 8. We're just simply going to plug all that into your calculator. You can use your calculator pi button, or you can use 3.14, whichever makes you happier. And you come out with, it's not a very nice number because pi is irrational. It's 301.44. We're talking about volume again, so you want to have, it'll be cubic feet. not hard. Just the area of the base. The base is a circle. Circle. The area of a circle is just pi r squared. That's this right here. Take it times the height and put it in your calculator. That's all you have to do. I'll give you this formula if it's on the test. Okay, one last thing, we're going to do some surface area problems. So bear with me while I go get the surface area problems. And again, I can't seem to find it. Hold on. This is lesson 72C. Alright, surface area. Alright, so we're going to find the area of a regular square pyramid, the surface area this time. A square pyramid is a little bit more special because all the sides are the same in the pyramid. There are special formulas to find the surface area of square pyramids. So this is the formula. The formulas are all in the back of the book. So in order to find the surface area of a square pyramid, it's just the side squared. Just remember all the sides are going to be the same. Plus 2 times the side times the slant height. This is the height. We're not concerned about the insides now because we're doing the surface area, so we don't care about that altitude thing. We're actually dealing with the slant height right here. So let's just plug her on in and get ourselves the area. So, making sure I'm doing the right problem. Okay, so you can either use this formula right here, this is the one in the back of the book, or you can notice there's 4 triangles and a base. So the base, the area of the base plus the area of all the triangles is the same thing. So the area of the base is our side squared. So we're going to just plug that in. Side squared would be 6 squared times, what we're really doing is we're figuring out all these triangles. So there's 4 triangles. So we can just use this formula here. And then I'll show you the other way. It's 2 times the side, which is 6, times the L stands for slant height. Kind of a silly letter to use. Times 5. This is the same as 1/2 base times height times 4, right? Because it would be 2 times, we will cross out, base times height. So that's all we did, base, height. And that's it's 2 because we're taking it times 4 because there's 4 triangles. So if we were to put this all into our calculator, that's what we would get, and we would add that all up. Make sure I did this right. We're going to get 96. And this time we're just talking about area, we're not talking volume. So we're going to have centimeters squared. Remember to put your units even when you're doing your homework because you'll forget when you do your test. If you don't have units on your problems, you'll automatically miss a point. Alright, the last problem that we're going to do. Sorry, this is a rather long lesson here. This time, a right circular cone has the base radius of 8 meters and a height, the slant height of 10 meters. Find the surface area of the right circular cone. Again, this formula is in the back of your book, and if it's on a test, I'll give you the formula. No need to memorize it. So what it is basically pi r squared would be the area of the circle down here, and pi times r is the radius, times L is our slant height once again. Just remember, slant height is L. You do have to remember that or else the formula will be useless. So we just plug it in. So it would be pi times r squared, so it would be 8 squared, plus pi times the radius times the slant height. We're going to throw that all into our calculator, and we're going to come out with a really fun number. It's going to be 452.16 meters squared. That's it. Hopefully you know just to use the formulas. This isn't hard, but you are going to have to know which formula to use. So if you have trouble, once again, I'm available and helpful at any time of the day. So that's it for lesson 72.